This is a modelling question involving numerical methods. So first up, we have the price of a car in pounds. X years after purchase is modelled by this function. You'll notice there's a trig function here, sine x. So we need to figure out, are we in degrees or radians here? Now it's not clear in the question, but if we look ahead to part C, we're going to be differentiating it. And differentiation needs radians. So for that reason, let's make sure your calculator is into radians mode straight away. Part A, we're going to use the model to find the value to the nearest £100 of the car 10 years after purchase. X years after purchase, that's what X represents. So we're going to let X equal 10 for part A and see what number it gives us. I'm just looking ahead to part B. Show that there's a root between 19 and 20. So across part A and part B, we're going to be subbing in 10 and 19 and 20. To make my job a little bit easier, I'm going to go into the table mode of the calculator. So you can go into table. I'm going to enter the function 15,000 times 0.85 to the power x, and then take away 1000 multiplied by sine x. That's my function f of x. The calculator asks if you want to enter another function. I don't, so just press equals again. Now for part A, I just want to find what is f when x is 10. So I'm going to start my table at 10, finish it at 10, and the step doesn't really matter here. So there we go, the calculator has done it. So for part A, f of 10 turns out to be 3497.13, etc. And the question says to the nearest £100. So to the nearest 100, that is £3,500. Part A done. Part B, show that f of x has a root between 19 and 20. So a root is where the function equals 0. So in other words, we need to show that this function equals 0 somewhere between 19 and 20. To do that, I'm going to go back to my calculator. It's going to press AC. Takes me back to the function. That hasn't changed. So equals again. This time I'm going to start my table at 19. I'm going to finish my table at 20 with a step of 1. So it goes up in ones. So that'll give me two numbers, give me 19, and it'll give me 20. Make sure you show this to the examiner. Show them what you have done. So f of 19, 134.11, and do f of 20 as well, minus 331.5. Make sure you give a reasonable amount of significant figures here. I'd say at the very least 3. And then tell the examiner that you know what's important here. There has been a sign change. And also the function is continuous. In other words, it doesn't have any asymptotes between 19 and 20. In fact, this function won't have any asymptotes anywhere. There's no danger of dividing by x. When I say no asymptotes, I mean no vertical asymptotes or vertical discontinuities. So yeah, it will be continuous. So we've got sign changed and it's continuous. Therefore, there is a root between 19 and 20. For part C, I'm going to need to use this result, the standard result from differentiation chapter. So using this, we get the first derivative of f is 15,000 multiplied by. So now to differentiate 0.85 to the power x, I'm going to use this result. So it's 0.85 to the power x times the natural logarithm of 0.85. And then differentiate, take away 1000 sine x becomes take away 1000 cos x. Part D, using 19.5 as a first approximation, apply Newton-Raphson once. Make sure you read the question carefully. You don't want to do it more often than you need to. So just once to obtain a second approximation for the time when the value of the car is 0. Remember, we determined that the value of the car is 0 according to this model, somewhere between 19 and 20. So using 19.5 as a first guess, we're now going to apply Newton-Raphson to get what should be a more accurate approximation. Give your answer to 3dp. So here we go, part D, applying the Newton-Raphson formula. If we call x0 our first approximation, then x1 will be our second approximation. And using Newton-Raphson, that'll be x0 take away f at x0 divided by f dash at x0. So there we go. That is our formula to give us the second approximation. Let's now put all this into the calculator. So I put all this in one go into the calculator. Some people like to do the numerator and press equals, then put the denominator in and find out that all in bits. I like to do it all in one go, but then look at your whole screen and check that you've pressed the right buttons. I've cleared my screen, but so you can't see it on here. And also double check we're in radians, which we need to be because there's differentiation involved. And the answer I got was 19.527, etc. And now checking what does the question want. Answer to 3dp. So 19.528, because the fourth decimal place was a 9. So it's 19.528 to 3dp. So that should be a slightly more accurate approximation than 19.5. So that was part D. Part E, criticize this model with respect to the value of the car as it gets older. So for part E, so here we are criticizing the model. So think about what we've just found. We found that the value of the car will reach 0 after about 19.528 years. And then, according to the model, it will then become negative. So it used to be positive, and we found there's a sign change somewhere between 19 and 20. So the value becomes negative after about 19.528 years. Now, negative values don't make any real sense in this context, so we could say that. So there we go. The question asked us to criticize this model with respect to the value of the car. So your answer needed to talk about the value of the car as it gets older. You also might mention that some cars, as they get older, actually increase in value. Okay, that completes this example.